Alright. So we'll start with the softest sound that you can hear. Softest sound that you can hear. What do we come up with? This is something you came up with on your own. We'll start with those first, and then we'll come up with something that you guys that looked up the specific answer. So who came up with something on their own? Mr. Brown?
I don't know. Maybe like your thoughts or something.
You can hear your thoughts. Isn't that more like a, what would you call that, metaphysical?
Psychological
or yeah. Yeah, so I'm not sure if thoughts actually have sounds.
Well, if they're just like really quiet.
Yeah. Interesting idea. Lane?
I couldn't think of anything, but I don't know.
Softest sounds you can hear. Asher?
I looked it up.
You did? Somebody else come up with something before we share those that I've looked up? Yeah.
A gentle breeze.
A gentle breeze. Okay, that's not bad. Briggs?
Blink.
A blink. You can hear a blink.
I've heard of blink.
You have heard a blink before. You got some slapping eyelids. Alright, who looked it up? Asher, you looked it up? What did it say?
20 micropascals?
Okay, so you're looking at like an actual measurement there. Okay, so that may be true. So I'm looking for something a little bit different, and this may vary a little bit, but this is according to the infamous purple textbook that we used a couple times ago. And in that particular text, it says that you can hear a watch ticking from like 20 feet away. Right? A watch ticking from 20 feet away. It uses that as an example. There would be many other examples as well, okay, such as a breeze, but they would probably have to be more specific about how strong is the breeze and in what context you are in. So this one gets really specific, a watch ticking 20 feet away. Sound good? Now, with this in mind, it's the softest sound that you can hear, and it's on the threshold of you not hearing it. Sound good? So what it means by being on that threshold is that 50% of the time you can hear the watch ticking from 20 feet away. 50% of the time you can't hear it. Everybody got that? So that's the statistics that I want you to remember. Half the time, or 50% of the time, you can hear it. Half the time, 50% of the time, you can't.
So why is it if it's less than 50%, like 25%, you can still hear it that 25% of the time?
We're trying to get that 50%, that half and half, and we're going to consider that to be our statistical threshold.
Okay.
And that's what we're trying to get at. Sound good? Number 2, what is the dimmest light that you can see? Examples? Mr. Bosworth? A candle from 8 miles away? It's a candle from, I think it's 30 miles away on a clear night.
Yeah.
Right? A candle 30 miles away, clear night. Okay? So that's about like the equivalent of seeing a candle. Peoria or Bloomington, we can see it from here on a clear night. Now the idea, again, it is on this threshold at 30 miles away. 50% of the time we can see it. 50% of the time we can't. Okay, now again, that is just one example probably of many examples that you could have with a sense of sight and on that threshold. Number 3, what is the most subtle taste that you can taste? Anybody got any examples here, Jared?
Water.
Okay, it's got to be something in water because water is, in and of itself, supposed to be tasteless. If we're going to assume that it's water, not like certain cities have a certain taste to water, right? But that's because of the substance that's in the water. So water, absent of the chemical and stuff like that they put in it, it should be tasteless. So the example that we have here to consider is a teaspoon of sugar in 2 gallons of water. Teaspoon of sugar, 2 gallons of water. That means 50% of the time, yep, I can taste the sugar. 50% of the time, nope, I can't taste the sugar. We have 5 senses. What are the other 2 senses that we're missing out on? Smell and the sense of touch. Okay. The thresholds for the others would be, or the examples for the thresholds, sense of smell would be, I think it's a drop of perfume. Must be a generic perfume. And I think it says a 3-room house. Is that right? 3-room house. Not a 4-room house, but a 3-room house. That's where you're going to get that threshold. 50% of the time, you're going to smell it. 50% of the time, you're not. And then their sense of touch. This is a good one. A bee's wing falling 1 centimeter from the height of 1 centimeter onto one's cheek. 50% of the time, you're going to be able to sense it. 50% of the time, you're not. It is on the threshold. Everybody got that? Yes.
Are we talking like kitchen, living room, bathroom?
I'm not sure. It just said 3 rooms. So. Right. It does leave a lot of questions.
Basically a whole room.
Right. Is it a shed dominium or? All right. So again, you may want to add this to your bell work today, but these are all examples of what we call absolute thresholds, and that's the terminology that we're really trying to get at here. Absolute threshold. And what an absolute threshold is where you can sense it, right? Or really, in this particular case, perceive it 50% of the time. Everybody got that? So half the time you can see it or sense it. Half the time you're not. That is on the threshold of the absolute threshold there. Sound good? So a lot of times, you guys remember doing the, I think it's the sound or hearing or auditory test that they put you through sometimes. At least a lot of times it was elementary school, maybe on some of the screening processes that's what they're testing is your absolute threshold. If your absolute threshold is passed, then yep, your hand goes up. I got it over here. Right, in my left ear, right, or vice versa over here. Sound good? All right. Let's go ahead and change both. We're going to take notes on absolute threshold, different thresholds, sensation, and perception. One of my favorite images to share, and it's also a, what would you call? It's an opportunity for me to talk about sociology, advertised sociology class, and try to get you guys to sign up for that as well. So how does this relate to sociology? So the question is, how much do you think that you could accomplish in life if you can neither see nor hear? You can neither see nor hear. Life would be much more challenging, wouldn't it? Right? If we couldn't see and if we couldn't hear at the same time. However, a lot of us, at least if we were attentive in elementary school, we would be more optimistic about a scenario like this because of one particular individual. Who would that be? Helen Keller, right? So we're all, I heard about Helen Keller before. She was able to do some significant things, right? She quite the historical figure. So if she was able to do it, then I'll probably be able to do it as well, right? We're a little bit optimistic about that. Okay. So the thing is with Helen Keller. The story that we're told in elementary school, again, this doesn't relate so much to psychology as it does to sociology. We're not told the full truth about Helen Keller, right? We're told about her accomplishments and able to overcome the handicap of not being able to see and not being able to hear. but we're not told about her political affiliations. We assume, she's considered to be like an American hero, that she would be a promoter of capitalism and the democratic system that we have in our cultural environment. But the reality is, it's far from that. And the reality is that Helen Keller is was a socialist sympathizer and an advocate for the communist political system, right? But why don't they teach that to you in elementary school? When they teach you about Helen Keller and all the accomplishments that she had, why don't they add and throw it in there? Hey, she's a communist, and hey, she likes socialism, right? Capitalism, no, she doesn't like that. Why don't they tell you about that? Crash on your parade, right? Right? Why is it in the first place they even use Helen Keller? I mean, they use it all the time. In elementary school, it's a huge component. Why do they do that? They use the story of Helen Keller to say that if she could accomplish great things, then that means that you that have the ability to see and the ability to hear, you are without what? Excuse. You are without excuse. It also says that the only thing, it actually implies this a lot. This is a big part of our American cultural system, which you learn in sociology. There's a lot of falsification associated with it. But the only thing that you have to do to be successful in life is do what? Work hard. Right? Put forth effort. That's what they want you to pick up from that story. It's all about effort. That effort is what is going to determine one outcome in life. And sociology tells us that there's a lot more variables that go into the success and failures that we have in life that are apart from, just one's effort there. Okay? So, why do you think she was a socialist, though? Going back to that idea. Mind-blowing, right? Why would she be a proponent of a social welfare state rather than the capitalistic system that we have? Yes?
She probably wanted everyone to be on an even playing field to start off with.
To start off with?
Yeah.
Okay, so why did she want that? So you're heading in the right direction.
Like, she had a lot of obstacles to face to, to get where she was.
She doesn't want other people to face the obstacles as well. Right, that's a good thought. Yeah. She was doing a lot of research, and she had the handicap of being blind and being deaf, and she realized that from her research, that statistically speaking, who is much more likely to be blind and to be deaf? What social class? The low social class. Those that are at the bottom lack the health care, they lack the education, the understanding to create a healthy environment. They lack the work environment, right? The healthy work environment to be able to stay away from these deficiencies. Okay? Those that are of the middle class and upper class, they are less likely to have to worry about stuff like this, right, than it would be for the lower class individual. Okay? So from her research and her understanding, she didn't want anybody to have to go through what she had gone through, right? So she was a promoter and an advocate of socialism and communism, rather than what we think of and assume associated with her today. Okay? So if you're interested in stuff like that, sociology is a good class to figure some of that stuff out. I don't know if we have any GIFs as hilarious as that one, but we have some good stuff in there as well. All right, our objectives today: identify the difference between absolute threshold and difference threshold, and answer the question, how does transduction enable the brain to receive sensory information? So we actually looked at transduction yesterday. Just want to remind you of that. We differentiated sensation from perception, and sensation is really just the activation of electrical impulses with neurons, neurotransmitters to our body. It's really not about feeling anything. It's really just about the electrical impulses and your sensory receptors receiving the stimuli. You only have the perception aspect is when those electrical impulses go through your thalamus, transduction takes place, and then you have a cognitive thought, a perception of what's going on. You guys ever been fooled by like plastic or wax fruit on a table before? You go into somebody's house and you see that sitting on the table there, and you're like, grape. Oh, a little waxy. Right? So sometimes the stimuli that we get exposed to, sometimes we can get fooled a little bit, and that's where our perception is not always the most accurate. The way our brain works is we have a tendency to fill in a lot of gaps and make some quick judgments, and sometimes those quick judgments get the best of us. But again, a lot of that is associated with the perception side, not so much the sensation side. Okay? Who has better senses, man or animal? Animal does, right? Why does animal have better senses than man? They can smell, they can see sometimes. Was that?
Know the prey.
Yeah, it's all about learning the flock and survival. They have to have heightened senses, not necessarily all of them, but at least one sense, in order for them to survive. Okay, we don't rely upon instinct to survive, and we rely upon really culture. We rely upon our prefrontal cortex and our ability to make decisions and to think clearly. That's what we use to survive. So since our emphasis is so much more on that, we have de-emphasized the idea of having to have a sense of sight or heightened sense of sight, sense of hearing, sense of touch, right? Sense of smell. So absolute and difference thresholds. Softest sound that you can hear. We've already talked about the dimmest lights you can see, most diluted substance you can taste. Again, those are all just examples. You could probably come up with a number of examples that are right there on those absolute thresholds. But again, it's half the time you can see it, half the time you can't. Okay, 50% of the time you can detect it, 50% of the time you can't. Minimum amount of sensory information. Okay, that's our absolute threshold. So we kind of covered that with our bell work. Do some of us have stronger senses, like a heightened sense of smell in this particular case, or a heightened sense of taste? I'm going to write this out to the side. This is a good test question. This is more towards later on, but for our census project, there's a name given to individuals. The answer is yes. All right. There's a name given to people that have a heightened sense of taste. I think it's pretty cool. They're called super tasters. As if they're like a superhero. Super tasters. They have a heightened sense of taste. And you usually, you'll find them on the Food Channel. They're the food testers that way. But they don't need like the extra salt on their food items to get the flavor out of them. They just naturally, they can taste all the flavor that's already in the foods. I always say that my wife must be a super taster because she never puts salt on anything that she cooks. And so I end up having to put salt on everything. Difference threshold. So the similar concept, the absolute threshold to difference threshold. How much must the volume be turned up to notice a difference? So we are going to assume that your absolute threshold has been passed already. You are aware that you're exposed to a particular stimulus. In this particular case, it's a sense of sound. Now, with that stimulus in place, how much must it change in order for you to notice a difference? Sound good? You've been exposed to the stimulus. How much must it change in order for you to notice? That's what's 50% of the time it changes to a certain point where you can notice it. 50% of the time it hasn't changed, or it's changed not enough that you can notice it. It's the same idea of the absolute threshold, but just for changes. There's a key term here. I don't have it written down. It's called JND, just noticeable difference. Just noticeable difference associated with difference threshold. What is just noticeable difference? That is the difference in the threshold so that 50% of the time you can detect it, 50% of the time you can't detect it. Sound good? All right. So this concept of the Weber's law goes along with difference threshold and just noticeable difference. What it says is that your just noticeable difference is really contingent upon the magnitude of the stimulus that you were initially exposed to. If the stimulus, the magnitude of the stimulus is great, then that means you're going to have to change it a larger percentage, right? A greater percentage in order for you to notice it. Otherwise, your difference threshold will not be passed. Okay? If the magnitude of the stimulus is really small of your initial exposure, then it won't have to change all that much for your just noticeable difference to take place. Okay? Give you an example. All right? This guy weightlifting. He's got a lot of weight on there, right? What if you say that you sneakily, came up to him? I know that he's on the brink of, not being able to lift this weight, but let's say that he's repping this stuff out like 10 times, okay? What if you sneakily came up and you put a 2.5 on, both sides, a 2.5 pound weight on both sides? Is he really going to notice that? He's repping it out 10 times, okay? No, he's not, because 2.5 in comparison to the amount of weight that he has on here already, that's such a small percentage that the just noticeable difference has not been passed. Everybody got that? You're going to have to put 25 pounds on both sides, right, in order for him to notice the difference because of the magnitude of that initial weight. Okay? Say this guy over here, that looks more like me. That's what I'm thinking in my old age. So what if you put 2.5? I know the obvious thing is you could see it, but in the distribution of weight here, it's a 2.5 or ultimately 5 pounds here is a much higher percentage with this guy than the previous guy. Okay, so just noticeable difference is much more likely to take place here than over here. What happens if you lose one of your senses? What happens to your other senses?
They're heightened.
They actually are heightened, right? It's like, you may want to write out to the side, plasticity. Brain plasticity is taking place when you lose one of your assigned sense. You can rely upon others to compensate for your loss of assigned sense. I've heard of people losing the sense of sight, and I see one guy, I've seen video of him, he'll actually do these clicks. And he can actually, through the sense of sound, and how it bounces off, the sound bounces off objects around him, he can figure out where objects are located in the proximity of himself just by clicking. Now, he can't see it, but he can hear the bouncing off of the sound there, okay? So your other areas are going to be heightened. Now, one really fascinating aspect of this is what happens to your brain, right? So you lose your sense of sight. What happens to the occipital lobe in your primary visual cortex? Does it just wither away? Does it shrink in size like a muscle not being used? Right? That's what our assumption is, but it doesn't do that at all. What it will do is it will use the other senses. It will reconstruct itself, again, brain plasticity, and take into consideration the other stimuli to still be able to create, even though you don't have a sense of sight, doesn't mean that you can't visualize, right? It doesn't mean that you can't use your other senses to be able to create some sense of imagery there. Sound good? So it's not like they're going to wither away like a muscle that's not being used. It doesn't do that at all. Think brain plasticity. All right. Last two concepts. Our eyes do not actually see and our ears do not actually hear. It's a good test question here as well. Is that true or false?
True.
It is true. Your eyes are just sensory receptors. Your ears are just sensory receptors. They don't actually hear. Right? Your nose, sensory receptor, for the most part. Skin, sensory receptors. Okay? They don't actually feel it. All that stuff, that perception, that's going on in your brain. Okay? That's because of transduction. Again, we talked about this yesterday. It's the process that separates sensation and perception. Sensory stimuli transform to signals with sensation, then they're sent to certain parts of the brain through the thalamus, and then you get that transition from an electrical impulse to a cognitive thought. Last idea, sensory adaptation. long-term exposure to certain stimuli actually lead to adapting to that stimuli, getting to the point where that stimulus, you decrease the level of awareness of that stimulus. Sound good? Because of your level of exposure to that stimulus. The example that I have here is for those of you that have a fireplace, like a wood-burning fireplace at your home. You know, in the fall semester, it works really well when we get to this particular time because it's getting colder, and a lot of students in their homes, they start to bring in the wood, turn the fireplace on. Over the first couple of days, you walk into the house, and what do you notice? The smell of the fireplace, right? It's a strong smell. You get 3 weeks into using the fireplace, right? You come home after 3 weeks, do you necessarily notice it as much as you did before? No, because you have sensory adaptation. I think the commercial with Febreze has identified it as nose blindness. You guys heard of that before? Nose blindness. Happens to everybody. You know, everybody's house has a sense of smell. The thing is, we don't necessarily notice it because we live in that house. We spend so much time in that house. You ever gone over a friend's house? You walk into the house, you're like, a little bit of a unique smell here, right? And you look at your friend, and you're like, don't you notice? And they're like, no, they don't notice because they live in it, right? They're not aware of it. Same thing like you guys coming into here, in this classroom. I imagine this classroom's got a unique smell. I can't smell it because I'm in here all the time. Sound good? All right? So it's a little bit different in that context. Your clothes are a good example of sensory adaptation as well. So it goes beyond our sense of smell, right? It's not talking about your clothes smelling here in this sense. I'm talking about you being aware of the clothes that you have on, right? Initially, when you put your clothes on in the morning, you notice that, hey, you know, I can feel the cloth against my arms, right? But as you go throughout the day, are you constantly, consistently aware of that? No, not so much, all right? And that's because of sensory adaptation. Now, one last thing, I guess, I forgot to mention this. Are there stimuli that are in our environment where sensory adaptation will not work? Well, you will never become, you know, have that adaptation to it, and you can't overcome it. You can't make that smell, you can't get used to it. You can't overcome it just by long-term exposure. Yeah, there are. If the stimulus is strong enough, it'll get the best of you. You'll never be able to have that adaptation, okay? Think about it like a skunk smell, right? It is so strong that you won't be able to get rid of it, okay, or get over it. Adaptation won't take place there, okay? High-pitched noises, you won't be able to, you know, develop an adaptation to that either. Sound good? Any questions about difference threshold, absolute threshold, just noticeable difference, transduction, sensory adaptation? Yes?
One of my music teacher actually talked to me about how people can hear difference in pitch and stuff. If you train your ear, you can hear it to like a certain level. Is it like difference threshold? Like if you hear a note is like just sharp or flat, like you can train yourself to hear it?
That would be a pretty good application of it, yeah. Yeah, that would. I would not be one of those people. Yeah, I envy those people that have the ability to do that. Percussion. I was limited to that because couldn't do much else.